Hello guys, my name is Anna. I'm your teaching assistant in the course of probability theory. So, in this video we will discuss some tasks which you may have on the test, but maybe not. We don't have, unfortunately, this information, which tasks exactly you will have on the test. But still, let's discuss some exercises. Some of them will be simple, some of them will be not very simple. So our first exercise will be the following. So we have 6 boys, 14 girls, and 1 ticket. So from this we may calculate that our set size is equal to 14 plus 6, which is equal to 20, and our event A will be that it will be girl, and event B is that it will be a boy. So how do we find the probability of event A? So we need to divide the size of A by the overall size. So we have 14 girls and overall we have 20 people. So our probability will be equal to 0.7. Speaking about the probability of the event B, again we will need to divide the size of B by the overall size, and we will get 6 divided by 20. Our probability will be equal to 0.3. So, and in sum, these probabilities will give us 1, because there are only 2 events possible in this case. So next, let's discuss the exercise in which we will need to use total probability formula. So the total probability formula is the following. Probability of B is equal to the sum of probabilities from I is equal to 1 to n. And here we have 2 probabilities. The probability of B under condition when event HI happens, and multiplied by the probability of the event HI. So our problem is the following. We have 3 guns. The probability of hitting the target is equal to 0.7. We have 5 machine guns, and in this case the probability is equal to 0.3. And we have 2 pistols, and here the probability of hitting the target is equal to 0.5. And we need to find the probability of event B, which we can describe as hitting the target and taking the weapon at random. So how do we know that we need to apply a total probability formula here? So as you can see, we have three different, so to say, parts. We have guns, machine guns, and pistols, and we have different probabilities assigned to them. And let's use the total probability formula. So our first event will be called H1, this will be H2, and this will be H3. And according to the total probability formula, our probability of the event B will be equal to probability of B under condition H1 multiplied by the probability of H1 plus the probability of event B under condition of H2 multiplied by the probability of H2 plus the probability of B under condition H3 multiplied by the probability of H3. Now we just need to compute the probability. So the probability of this event, probability of H1, it means hitting the target by a gun. It is given, it is equal to 0.7. Speaking about this probability, here we need to look at how many guns we have. We have 3 guns. In total, we have 3 plus 5 plus 2, we have 10 different weapons. Among them we have 3 guns, so we take 3 and divide it by 10. Then again, the probability of, we need to find the probability of having a machine gun. So we have 5 machine guns and 10 weapons, and we then multiplied by the probability of hitting a target by a gun. So we multiplied it by 0.3, and finally the probability of taking a pistol will be equal to, we have 2 pistols and 10 weapons in total, and then we multiplied it by 0.5. And after some calculations, our final answer will be 0.46. So, great. Now let's solve an exercise where we need to use Bayes formula. So firstly, what is our task? So we have a family, parents and 3 daughters. So we have 3 daughters, Alice, Barbara and Charlotte. So we can name them as A, B, C for convenience. And we know that Alice washes the dishes in 50% of the cases. And the probability that she breaks something in this case is equal to 0.00.5. So the probability of breaking. We know that Barbara washes the dishes in 30% of cases. And the probability of breaking in this case is equal to 0.004. Charlotte washes in 20% of cases, and the probability that she breaks something is equal to 0.07. So we need to determine who washed dishes most probably, if something was broken. So again, in this case, we will name the first event H1, the second H2, and the third H3. So R will be event that something was broken. And now we need to find the probability that Alice washed the dishes under condition that something was broken. So we write probability of event H1 under condition of R. And to find this probability, we will need to multiply the probability of breaking something, let it be so yes, the probability of R under condition of H1 and multiplied by the probability of H1. So our probability of breaking something in case of Alice is equal to 0.002, and the probability that she will wash the dishes will be 0.5. And in the denominator, we will have a sum of probabilities multiplied by other probabilities. So we will need to multiply this probability by this one, this probability by this one, this by this one, and sum them up. So 0.002 multiplied by 0.5 plus 0.004 multiplied by 0.3 plus 0.007 multiplied by 0.5. And after computations, we will find that the probability of the event H1 will be equal to 10 divided by 36. So the same approach we can use to find the probability of H2 under condition of event R. So I will not repeat the same formula because it is the same, just in the numerator we will have another probability. So this probability will be equal to 12 divided by 36, and this probability will be equal to 14 divided by 36. So to find the last probability, we can just take 1 minus the second probability minus the first probability, and we will receive 14 divided by 36. So it is not, you don't need to compute this formula again. You may use this one, or you may compute it by the Bayes formula. It is not very important here. So, and to answer the question, we need to find the largest probability, and the largest probability here is this one, 14 divided by 36, and it was Charlotte who washed dishes most probably if something was broken. Now let's proceed to the next exercise. Here we have two fair dice, and we know that the first shows number 3. So our set of events is equal so our die can show 1, 2, 3, 4, 5, 6, and let's name the event A such that the sum of numbers on dice will be bigger than 6, and the event B will be that the first die shows 3, and again we have some conditions. We have that the number of points which are shown on the second die will be between 1 and 6. And we need to find the intersection of the events A and B. So this will be this set. Firstly, when the first die shows 3 and the second one shows at least 4, because in this case the sum will be 7, which is greater than 6. Then our next item will be 3, 5, because it will be 8, which is greater than 6. And the last set will be equal to 3 and 6. So this will be the intersection of A and B. And speaking about the probability of A under condition of B, we will use the following formula. We will use the probability of AB divided by the probability of event B. Here we will use the size of the set AB, and here we will use the size of the set B. So here we will have 3 items, so this one, and this one, and in total it is possible to make 6 combinations when the first die shows 3 and the second one shows 1, 2, 3, 4, 5, 6. So in total 6. So our probability will be equal to 1 divided by 2. So now let's proceed to the next exercise. It will be about Bernoulli formula. But firstly, let's see what is this formula. So Pn k is equal to combination from n by k multiplied by p in the power of k multiplied by q in the power of n minus q, with the condition that k is between 0 and n. So k here is number of successful, let's say, trials. N is the total number of trials, and n minus k is the number of failures. So our example, so we have 2 shooters and they want to hit the target, and the probability is 1/2. The first shooter tries 4 times. The second tries 8 times. And there is a question: what are the probabilities that first has 3 successes and the second has 5 successes? So as for the first one, we know that he tries 4 times. This means that n is equal to 4 and k is equal to 3, because we need to find the probability that he has 3 successes. In this case, we can use Bernoulli formula. So instead of n, we take 4, instead of k, we take 3, and by the formula, we will find that it is a combination of 3 taken from 4, multiplied by 1/2 in the third power, because it is the number of successes, and multiplied by 1/2 because it is the number of failures, and it will be equal to 4 multiplied by 1 divided by 2 in the power of 4, and in total it will be 1/4. So the next probability which we need to find is that the second player has 5 successes. So in this case, we know that he tries 8 times, so n is equal to 8, and we know that we need to find the probability about 5 successes, so k is equal to 5, and our Bernoulli formula will look like probability of 5 successes from 8 trials. So here we have combination 8, 5 multiplied by 1/2 in the power of 5, multiplied by 1 divided by 2 in the power of 3, and it will be equal to 7 divided by 33, which is less than 1/4. So in this case, we had the probability which is equal to 1/2 in both failures and successes. But when you will have the probability, for example, 1/4 will be probability of success and 3/4 will be failure, you will need to use these numbers in the formula according to the Bernoulli formula. So you will need to put the probability which corresponds to success and to failure.